share the screen and show you. I already uploaded the file onto the drive. So you can actually implement this in using ResNet and VG16 and all the other transfer learning stuff, because we have already shown you how to do transfer learning and face detection as classification I showed previously, and I was talking about Siamese network, but we found that it is not Siamese network, right? So I gave the solution here. I found solution here. So I loaded the image, and there are around 15 distinct subjects, or 15 different people, images belonging to 15 different people, and each person has got multiple images. Yes. From here till here, one person image. From here till here it is another person. From here till here it's another person, like that. 15 different people pictures are there, and there are around 160 166 pictures. So whenever we are trying to do the face detection model, we should have a single person's multiple pictures. We should have. Okay. So the same is being satisfied here, but the data set is small. And generally 16 pictures are not sufficient to generate a network that will embed or that will encode your picture into a small picture, small dimensionality, at 128 dimensionality. So make triplets is the function that actually makes the triplet data set. Okay. So make triplets is the function. So here in this make triplets, what I am doing, I am actually taking one image as the anchor image index, right? From total range of indexes, I have taken one index, first index, and then saying that image as the anchor image. And for that, the POS label, the subject name, right? Person name is the POS label. I've taken that as the POS label because in this label, another picture I will select. Okay, and apart from this label, I will select another picture. So that's going to be a triplet. See this anchor, positive and negative. I need to choose, right? So in this loop, for every anchor for every anchor index I have chosen, I am creating 10 records, right? Anchor positive negative, like that 10 records I am creating. And for all the records, target variable is one only, because we are not going to use this target variable while training. This is just to satisfy the deep learning models, whatever the signatures, the method signatures. Okay, so I have taken positive index, right? I randomly chose the, see here I created a dictionary of different classes and their indexes. So if you see this class name, subject 1, and all the indexes where the subject 1 is present, subject 2, all the indexes where subject 2 is present, or person name, all the indexes present, person name, all the indexes present, like that I have done. So this is an array, right? This is a class name or the person name. This is array of indexes. So from there, from the dictionary, I am choosing all those indexes that belong to this particular person. POS label is nothing but person name, right? So I am choosing one index out of them. So randomly I chose a positive index and I picked a positive image. Same with the negative, right? So all the negative labels I have taken, chosen one negative label that is not the positive label, right? Current person's name, apart from current person's name, I chose one name randomly, and then I took one of the indexes there and chose that as the negative image. So I created triplets like that, and the label for target label is 1. Okay, so I hope you are understanding. let me try to open that slide and try to explain. I think you got it, but as I implemented it, right, I'm trying to show. So this is the concept I am trying to implement. Anchor, positive and negative image, and a triplet class. Okay. So any questions here? I am forming the data set.
Sir, here you took that face index dictionary, right? So, where is the arrays, sir? This class arrays?
That's a good question. So if you look at this particular code block, this part, np.where is a method in NumPy which actually
Yes,
gives you where that all the indexes where that this condition is satisfied. So this is y is a NumPy array, right? Y is a NumPy array. CLS is a class in the classes. All the distinct classes I collected. Unique,
Unique, okay.
names, names in Y train. Right? These are all different names of the people. Right? From that, I have taken class and trying to
Class.
pass it to this in a list comprehension. Got it?
Yeah, I got it.
This is dictionary. This is
Yeah, this
class
is
name colon array of indexes where that class is.
indexes.
Class name colon array of indexes. So that's how I created a dictionary.
Yes, sir. Got it.
See, if you see the whole code, whole project, like this whole training, I'm using what I trained. I'm using all those techniques what I actually trained from the day one. Apart from that, I did not use anything. So for AI/ML, whatever Python we learned for 3 days is more than enough. Okay, a little bit of classes, the class creation and the underscore init method. Those things you need to understand a little bit. I did not give stress there because some people don't know Python or programming. They'll get confused. Okay, once you are familiar with all this, right, you can go back and look into classes and get more clarity there.
Yeah, so
Yeah.
here we have actually taken 15 images of a single person, right?
No. 15 different people there. Subject one means one, person two, person three.
Yeah, how many photos of each person, sir?
It is random. There are actually 166 photos are there.
Mhm.
But for some there are 3 photos only. For some there are 10. You see this guy. This guy has got around how many selected? 12. Right? But this guy 11 only. This guy 11. This guy 11.
Yeah. So
Right?
do we
This guy.
need to take the anchor image as the same image, or it can be any image of the person?
So all people I am creating. First, this is if you look at this for loop, right?
Yeah, I understand that, sir. But let's say if we are talking about only one image,
Okay. What to do
so
when we have only one image of the person?
no, we are actually doing one image by image, right? In the for loop. So
Yeah.
there are 5 images of a person, and we are taking anchor, positive and negative. So the anchor should be same for positive and negative pairs.
Yeah. It's one row and it's a one row. Anchor should be same for positive and negative. Got it?
Yeah, right. That is right, sir. Yeah.
Your question
Previously,
is
like there were 2 pairs, right? That's where.
maybe let me reframe your question. Whether I understood it correct or not. So I am taking this picture
Yeah.
and then taking this picture as positive image and this picture as negative image. Okay.
Yeah.
And again the same picture, right, in a for loop. right? Here there is a for loop, 10 for loop, right? That 10 for loop, right? What I'm doing, I'm taking the same person, taking maybe this picture as positive, this picture as negative. Same person, this picture as positive, this picture as negative. Like that I framed 10. Okay, that's over. In the next iteration, I'm taking this picture. And again taking one more picture, positive, one more picture negative, something like that, right? Got it?
Yeah.
Is that your question?
Yeah, that's correct, sir. My question was actually based on previous understanding. Like there were two pairs.
Okay.
Actually, with this one pair, that question doesn't have any meaning.
So that is actually an approach called as face recognition as classification.
Okay.
This is called as triplet class. This is called as one-shot learning. Okay.
Yeah. So as we discussed, like face detection as a classification. There, for positive and negative, do we take the same anchor and take a positive for that anchor and take negative as for that anchor?
There I have taken like that only. Positive, one anchor and positive and negative I taken. Yeah. Two records will have same anchor.
Okay.
Like that I have taken there. We have to take like that only, but the model was not working well. So this is the, I renamed it and I saved it into the code files. These files are useful in your real time also. I don't know whether you're noticing it or not, but these are pretty much useful. You can do many things with these. Today, tomorrow we'll look into some NLP stuff, and that's even more useful. Okay, so this is this is classification stuff, right? So this person positive, this person only negative. Okay, and you see the accuracy is not improving. Sometimes it is coming 70%, sometimes it is 40, like that. It's oscillating very bad. But this triplet class thing, right? It is working very well. Okay, this is how the data set is formed. Positive. Actually, it took the same image as anchor as the positive. We randomly chose. So I should write more stringent code here, not to choose the anchor image as the positive image. Right? Something like this. Something like. Yeah. So here I should write like this. Positive index is equal to anchor index, right? Here, while positive index equal to anchor index, right? Loop. So this way, what happens? While this condition is true, the loop will run. It will choose some index, right? That index is equal to this. Again, it will choose like that, right? So on the negative also, it should not choose the previously selected negative index. So there are 10 indexes, right? So I should create some list of indexes here where I should write, not in, choose an index which is not in that previous 10 indexes. Each iteration, I should choose something like that. I should write. So I did not write that. That's where it is actually choosing sometimes it is choosing random, right? Sometimes it is choosing the same anchor image as the positive image and a negative image I have chosen. And now here I normalize the data. I have created my own network. This is the network which is going to create embedding or encoding of the 128 dimensional encoding of the picture, right? And then Euclidean distance is not used. Identity loss yesterday we have seen. It is using Y prediction only. Y prediction is nothing but loss, and the model is trying to reduce the triplet loss. So triplet loss is the layer, the output layer also. So if you look at this, we are creating 3 input layers for anchor, positive and negative, passing them, creating 128 dimensional vectors for those 3, and then passing it to triplet loss. So when we actually do this and train, what happens? This model is getting trained. The weights are getting adjusted in such a way that the loss gets reduced. Okay, so output is loss, and the loss function is also mean of all the losses in the batch, right? So I started training. I kept some early stopping. It did not work for some reason. See this here? It started with some loss there, and it reduced, and it became 0. By 17th iteration, it became 0. Okay, 30 iterations I have taken. Now you can, I have saved this model. Right, face encoding model is the outcome. I have saved that model. We shouldn't be saving this model. This model is of no use. We should be saving this model. I hope you got that point. Right? So that's the model we use, and pass a picture and convert into 128 dimensional. First, what we will do is, for all these 15 different people, we'll take pictures, 15 pictures, convert them to 128 dimensional vectors, save them into database. A new picture comes in, you pass that to this model, convert it into 128 dimensional vector, then check against the database, whichever is closest, you say the person belongs to that particular, the photo belongs to that particular person. Got it, right? Can I move on? I think we are done with this face detection. Okay. So yesterday we actually saw how to implement one-dimensional convolution on text data. Right? So yeah, using using word2vec we have seen. Today we'll see how to use glove, right? Glove model. So I have used random oversampling here. I think I don't know whether I used it or not, but this random oversampling. Do you remember oversampling, undersampling techniques? Where it is useful? Do you remember undersampling, oversampling?
I think if the data is less, then we have to do.
Imbalanced data sets. We may try the oversampling and then build model, undersampling and then build model. Generally, oversampling works than undersampling because we will not lose data. Right? So random oversampling, this IM balance, IMB learn is a module which has got oversampling, and then in that random oversampling is there. It actually randomly chooses records and creates more. Okay, here this data set is imbalanced data set. There are 30% records belonging to bullying records and 60-70% belonging to non-bullying records. So that's where I kind of maybe did random sampling somewhere. But data set I have taken, cleaned it up, and I did random oversampling, right? Fit sample, and then I passed whatever, right? So X and Y. So I created more records. And then see it is balanced now. 1 records and 0 records are balanced. See, 1 record, 0 records are 9,000 in the whole total data, not in the train set, right? In the train set it will be less. So 1 records are 4,000, right? So I did oversampling and we have got more records here. And this was built on 2.0 version. Now it is 2.4. So pre-processing, I did some text, whatever. Now I have downloaded. I have shown you that there are pre-trained, word vectors present in this place, right? This Twitter data I downloaded. Okay. So the 28 billion, 28 billion tokens they have taken and they actually created the word vectors for those. And in this zip file, right, you will have 200 dimensional vectors, 25 dimensional vectors, and 50 dimensional vectors. I would have taken 200 dimensional vectors there. So you need to do, this is around 2 GB. This file is around 2 GB. So, to do AI, ML, you need huge memory, huge hard disk, huge processor, huge GPU. It's all expensive stuff, right? So companies should provide. Okay, some people who don't know deep learning, they don't even know why we need that big a laptop, that big a computer, and that big a GPU. I have seen people, right? That's very sad. In industry, I have seen them. So, okay, so I have taken this 28 billion data set and 200 dimensional whatever vector. Okay, so to convert your our glove file into word to vec, why are we converting into word to vec? If we have it in word to vec format, right, we can use this word to vec model dot get vector, right? This is a vector for mkr, some term, some word. If you say give, get, any word you give, you will get a vector for it. Okay, it is trained on 27 billion tokens. It must have some context sensitive, knowledge, right? These vectors must have some context sensitive knowledge. Will it work for all the data? No. For cyberbullying, it may work because it's a Twitter data, it's a social media data. You may have similar kinds of bad words used in these Twitter accounts also. Maybe, may not be, right? So to convert it in GenSim, we have got get temp file, right, and data path, and then keyed vector, and glove to word to vec. This is the important method, which actually converts a glove vector into a word to vec vector. Okay, so when you convert it, right, it's a two. I think it's a big file. So you in memory you should also you should have huge amount of RAM you should have. Right, try running this on your machine, see what happens. Okay, then in interviews, right, you can actually answer questions as you know. Right, if you don't experiment or run my files, whatever files I gave, even if you say even if you know theory, the interviewer can catch hold of you because some things you don't know, practically you don't know how much memory, how much processing, and all those things you don't know. When you don't know, you will talk in an unawareness, right? So that can be sensed if the person is really knowledgeable, right? So the glove file I have taken, and then temp file I created, right? And then glove file and temp file both we need to pass to glove to word to vec. The outcome is not needed because in the temp file, the glove file is going to be translated to temp file, and using that temp file, right, we can actually load it as. So basically the glove model I converted into word to vec model. That's it. What is this model? This is nothing, right? Glove or word to vec ultimately creates vectors from one format. There will be these kinds of vectors present in this text file. This word to vec guy actually wrote some code to convert, create a word to vec model kind of an object where all those methods will help. VW, get vector, all those methods will help. Okay, work. So I converted it to word to vec and I saved it, right? I commented that code, and now I am using that, the glove model vectors and building same thing, right? Generate vector, same code, split batch, same code, right? It's a generator, and again data set, right? tf.dataset from generator, to build this code, right? I took around 3-4 hours, because the signature was not clear. What to do with output types and output shapes. So you have it right away. You can actually copy paste and use it. Right? The same, con 1D, max pool 1D, right? Flatten dense layers and all that. Okay. So model compiled and trained, and we have used early stopping and monitoring validation accuracy. So in your data set, in your fit model, train set is there and test set is there, right? If you say patience 10, restore best weights, it will look for 10 iterations to change the if the error between the previous iteration and the current iteration is less than threshold, less than tolerance, it will actually wait for 10 iterations. If it for 10 iterations, if it is the same case on validation data set, then it will break and restore to the best model it found on those 10 iterations. Okay. And I think I have taken this test set and tried to predict here something like that. So okay, this is another glove based deep learning model to do text classification. Any questions here? I'll show you character based.
So
yeah.
So if we are thinking like this is a glove based model, or we are using glove based vector representation, numerical vector representation. So why are we converting that glove-based vectors into a word-to-vec?
Because we don't have API to access those vectors. In glove, it is, see this website, see how it is. They have given just the text file with all those vectors in there. Words and vectors combinations. Maybe you can create a dictionary and use it also. I converted it to word to vec because it's easy, right? My code is already there to actually create extract vectors. See this word to vec dot vocabulary will come, right? Word to vec of word will give me the vector, right? All these things, I want to use the word to vex API sophistication. If you don't want to use it, you can just create a dictionary by looping through the text file.
And then pass that to the model?
Yeah, you can pass that to the model. Or you can do one more thing. In this data set, I am using a split batch method, right? The split batch method can actually read through the text file, maybe the lines, counting lines. On the fly, it can create batches. Got it? Here I loaded everything into memory. When I converted it to word to vec, I loaded everything into memory. Right? And then I'm saving it as a pickle file, and anytime I am running, I'm actually loading that again into memory. Instead of doing that, you can actually write code to read n number of batch records, randomly whatever, right? Randomly pick words, or no, not randomly pick. For each word, you actually go to the file and bring it, rather than loading everything into memory. If your RAM is low, you can use that approach. Or you can dump this whole data into a database, write query to pull out a particular word's vector. Got it?
Yes, sir. So we are actually taking that Twitter related glove vectors.
Yes, Sandeep.
And it could contain many words, right? So where are we actually
27 billion
only, where are we taking only those matched words which are there in our data set?
Yeah, 1.2 billion vocabulary it is, So if you look at this split batch, right, what is it? your question is,
So you are actually breaking, sir. Maybe that is with me only.
question. Sorry, I think there is something went wrong. Is your question where are my sentences or where are my documents and how am I getting vectors, right?
Yeah. The vectors are predefined, which are taken from the Twitter data. Those are vectors of many different words, some billions of words. But those are all not the words in our actual data set, right?
See this here, the highlighted code. You can see my screen, right?
Yes.
Right here, what we are doing, we're taking a batch of sentence pass to this generate thing, and from there we are actually getting word vector model is nothing but glove model only, right? Here, because I converted word vector to glove to word to. Got it? From those 1.2 billion vectors, sorry, million vectors, I am getting my words vector.
Okay, sir.
Got it?
Yeah.
You can write this, instead of loading everything into memory, you can write it as a, on the fly getting thing also. That is better. That is actually memory efficient. Anyway, training will take a lot of time. So, reading from memory, reading from database may add a little more time. So, it's always better try to read from database. It can be big data. It can be, it can be Oracle. It doesn't matter. So this TF data set is very important, and it will actually give you all these methods. Okay, so this is one model, right? The third way is that character-based model. Yeah, this is character-based model. So far, right, in to vec and glove, seen each word converting into vector. Okay, the other way is that that route actually take each character as embedding. Each character as an embedding. If you want to take each character as an embedding, you can give number to each character. Right? There are 26 characters in English. Apart from that, there may be less than, greater than, these kinds of symbols. Maybe 256 numbers, right? ASCII has got 256 numbers, 256 characters, right? Maximum 256 numbers. Each character you give one number, that you call it as embedding. Do you agree? Right? Do you agree? So the other way of representing our data into numbers, I am actually trying to explain. Character-based, model means we are actually trying to understand. We are trying to take each of the character as a embedding. Okay, let me write it and explain. You got my idea, right?
Yes, sir.
This is a very important concept, and this is useful when you are actually working with multi languages. Okay, so I'll show you in a moment. Flare, right? Flare is I showed you spaCy, right? A little bit. I showed you spaCy, right? spaCy module I showed you. Did I? No.
I think no, sir.
Yeah.
I do not.
So yeah,
I forgot.
Yeah, I'll show tomorrow. Right? Maybe today, if time permits today. Right? Why am I talking about these modules? Because they have pre-trained models, and they have given customizable approaches to make those models work on our data. On the fly, on the shelf, they will not work. Most of the times, they may not work. But if you customize them to your needs, it works. When you will be able to customize them? When you know everything, when you know the internals of the of how it works. So Flare is a module or NLP that actually works with character-based models. And when you, what is the advantage of character-based models? If you take the glove as an example, those guys actually trained on Twitter, and the word vectors actually are created based on Twitter data. Okay. Now you are working in a healthcare company and you have healthcare data. Can I use the same vectors of the glove to solve my problems in healthcare domain? Can I?
I don't think so, because different words have different meaning in the different context.
Yes, we cannot use them, right? We cannot use them. So we should train our own word embedding model on the data we are working on, depending on the domain. And if the corpus is already available, already somebody trained it, then fine. If it is not available, you should train on your own, right? So that's where in the word2vec I was always showing you to train a model, right? Word vector model I was actually showing you. So if you take the glove or word2vec and you trained on one particular data set and not another particular data set, the vectors may not work, right? That is one problem. The next level problem is there will be different languages. In healthcare domain, if you go to any healthcare domain big company, you will have same documents in multiple languages, maybe around 20 languages. Same document in the sense not the same. Text will be different from different branches of their companies, from different countries. They'll have letters, right, for approval, maybe for submission, maybe whatever for drug approval. Okay, so all these letters will have same context, but language is different. So in that case, what you need to do, you need to actually take the data from different languages and then train your own word2vec models on different languages, and then use word vectors for each of the language to build models for each of different language. Got it? Did you get the problem? Overall big problem. Big problem with word2vec based on words. No? Yes? Did you understand?
Can you please come again, sir?
Okay, so you have, let me take a simple example. Yeah, resumes. Okay, so you have resumes. Suppose that you created a HR company throughout the world. Okay, you want to work. You want to this is a business idea basically. So you want to throughout the world. Okay, and you want to provide the services of these resources to the clients in a way that is profitable to client as well as the resource. Okay, it's like in US there is like when you find a job, you are doing consulting, you will get 80% and your employer will get 20%, right? Like that, such kind of a model you want to create. A HR company, worldwide HR company, which actually does this. Okay, so to shortlist resumes, you don't know English, right? Basically, you don't know English, and you want to build a model that actually finds resume that are uh, uh, technically strong in Java. Okay, so you have resumes from India, you have resumes from Spain, you have resumes from Turkey, you have resumes from Iran, like that. Okay, Pakistan, Iran, right? Throughout the world, you have English and your mother tongue. Okay, the advantage there is that each of the resume has got labels, right? Labels in English. Okay. So suppose that I am from Spain, Shashi is from India, maybe Girigaru from maybe some other country, maybe in UK, something like that. We have the resumes in our own language, but there is a field that actually specifies which are all the technologies that person knows in English. Okay, this is the data set. Okay, so we know the classes to which the document belongs to. Okay, now a new resume comes in. I need to find whether that resume belongs to Java or not. This is the problem statement. Did you get the problem statement now?
Yes.
Right. So there are multiple resumes with multiple languages, but we have a target variable which actually specifies for each resume there is a target variable. Resume is the input variable. Target variable is the technologies the resume belongs to. The target variable is always in English. The input variable is in different language. Let me write it down. That way it's going to be better. So let us formulate the problem, because this problem is there, in the industry. Basically, this is what we try to work on, and I got pissed off because of the way the people are handling it. Okay? So resume 1, right? English, EN. Resume 2, Spanish. Resume 3, Italian. Right? These are languages. Okay, and the target variable, this is X, I'll say. That's why it says this is Java, web development, web dev. This is data science, AI, right? This is again Java and .NET, right? Like that, like this, right? I have a million resumes. Okay, now I need to build a model, AI model, by taking these all, this all data as input, and then and when a new resume comes in, right? New resume. Let me take another color. New resume. Right? Maybe this is like this is maybe Spanish. Right? Resume new. Okay. I need to predict which technology this resume belongs to. I need to predict which technology it belongs to. So I'll pass this to model, and it will actually predict whether it is Java or whatever, .NET or whatever. That's the problem statement. Okay. So can you design a solution for this? If we have to design a solution, how will you design it? How will you convert your text into numbers, and how will you format your data set and all that? Can you tell me?
Yeah, so based on that, we have predefined labels assumed, sir, like Java, .NET, some XYZ labels is what we are interested in. Assume that is what we have some interested labels. Okay.
Yes, sir.
Then in each resume, we'll check if these labels are present or not. Accordingly, we'll all segregate.
Yeah, segregate. But as a data scientist, right? How will you? What is the first step you do? What is the next step you do? That's the question I asked, because that's where the key is, right? Because if we go like that, right, we will know the problems with word vector representation, and we will understand why we are actually doing the character based model, or character based embeddings and character based models.
Yeah.
That's where my problem is now.
Understood, sir. So maybe one raw way is one hot encoding for the A labels which I'm interested in. For example, Java one label and .NET and XYZ. For each resume, I'll put that one label 1 or 0. That is one way. Second one is for each resume, I'll maintain an array of labels that are available. There are two different ways I can think.
What you're saying is, this y variable is going to be like Java, .NET, right? Maybe all the other different technologies there. Okay, this is y variable, right? Y1, Y2 like that. Okay, this is what you said, right?
Correct, sir. For every resume, I'll map Java 1 or 0, .NET 1 or 0, like that. I'll map. That is
Yes, sir. Yes. Good,
not
good,
in
good.
efficient way. Second one
Yes.
is for every resume, I'll map just list of labels available, which are ones, only ones. That only I'll map. That's another way.
That way may not be appropriate, sir, because if there is Java and .NET in one resume, and if there is Java only in other resume, it will actually consider both as two different classes, right? That guy is eligible.
Yeah.
That resume is
Right.
eligible, actually, right?
Correct.
So this is the right approach, basically. Okay, this is one right approach, right? What about X? What you do with the resume?
Yeah. Resume, I think whatever all the text that are present and the skill set, all those things we need to somehow represent that. Yeah.
Yes, and
Mm.
somehow represented means
Yeah.
like uh,
Yeah. Each word
somehow
has
you want
each
to.
word.
So there are, there are bag of words approach, TF-IDF approach, right? Bag of words is count of each of these words, right?
Yes.
Java is present, or .NET is present. In X also, in resume also, you will have Java .NET. Okay.
Yes, sir.
Right. I am talking about English only now, right? Remember, English only I am talking about. English. Okay. English X. Okay. So TF-IDF term frequency is nothing but log of the whatever bag of words counts, and then IDF is the try to nullify the most frequent words and all that stuff. Okay, that's another way. The third way is word vector representation, right? So out of these three, which approach is better to represent a resume? Word vector can be word to vec or glove. Yeah, word to vec or glove. Yeah. So word to vec is the right approach, right? But why it is the right approach? Why is it right approach?
Memory point of view, sir. Lesser memory or faster process.
Oh, no, sir. Word to vec will take more memory. Because each word you represent it as a 300 dimensional vector. There are 1 million words, 1 million into 300. That many bytes, that many 100 into 1 million into 3 bits. It is memory wise, it's not going to be efficient. But
I think it's accuracy, sir.
Huh?
Accuracy point of view.
Accuracy, semantic similarity, right?
Yeah.
Resumes, you write your own language, I write my own language, but the word be different, but meaning may be same. That will be extracted when you actually represent your words in a vector format. Okay.
So to
So in
represent,
resume data,
sir, to represent Java also, like as a whole, whether the resume belongs to Java or not, there could be many words, something like strings, stars, all those stuff. Java means it's
yes,
not just Java, right? Java contains
yeah,
many different words.
yes. When the technology stack is mentioned, right, there will be all these surrounding words, right? Surrounding Java, there will be Linux, maybe there will be DevOps and all that stuff, maybe, right? Maybe Spring, struts, all these things will be surrounding words. Basically, it will create the vectors will be created appropriately. Okay, so you can use word to vec and build a model. How do you build a model? How do you build a model? You take these word to x, vectors, right? Your document, resume one becomes a two-dimensional matrix. You pass that to a con 1D, Con 1D, maybe max pooling 1D, maybe, max is needed, not needed, we don't know. And then dense layer, and then you pass your, this multiple, if the data is like this, right? Suppose that there are 4 technologies: Java, data science, and big data. Okay, 4 classes are there. All 4 are binary. It's a multi-label classification. In a deep learning model, how many how many nodes should be present in the target layer? Output layer? 4. Of what? What is the activation function in these 4?
Softmax.
No, logistic. Because each of the node is going to predict either 0 or 1. 0 or 1. If each of these node has got, each of the target variable has got multi-class, right? Then softmax. Got it?
Yes, sir, that's right.
Understood, right? So in deep learning, you can handle multi-class, multi-label very efficiently, very easily. But in machine learning, right, only some algorithms support. If algorithm is not supporting, you have to build independent models. You take all X, take one column, build a model. All X, take another column, build a model. Take X, another model. So 10 models, you need to pass your data to 10 models and make predictions and combine that and return it as whatever in machine learning. But deep learning, in a single shot, you can actually build that. Okay. So we are understanding better, I think. We are trying to understand more things here. Okay, this is how you can do it. Okay, so resume 1 or resume 2, resume 3, like that. All 1 million resumes I passed and I trained. This is all English. Okay. So for English language, I have created one word-to-vector model and used those vectors and built a model. For Spanish, I need to build another model. For Italian, I need to build another model. Because if you try to combine all different languages there and pass it into the word-to-vector model, right? It may get confused. It may get confused because the context words, surrounding words will change. When you actually combine the whole data and you are randomly picking the words, what is word2vec doing? It is choosing a word within window, one word, and k number of words from outside window. Do you remember that? How word2vec is working? Do you remember?
Yes, sir.
While forming negative sampling, right? Negative sampling data set, while forming it, it is picking one word from within window, right? If you say window size 2, left 2, right 2, it will consider. I like deep learning, right? For deep, it will actually take deep learning classes, I say. Learning classes and like deep, I like, it's going to take as the surrounding words, right? So from out of those 4 surrounding words, it will choose one, and in the total corpus, it will choose around k number of words. So in the total corpus, when it is choosing, right, if it chooses some other language, the vectors will get confused and vectors will not have the will not get the essence properly, or the semantic similarity may not be extracted properly. Okay, if you combine all different languages. So for English, you need to build one word-to-vec model. For Spanish, you need to build another word-to-vec model. For Italian, you need to build another word-to-vec model. Like that, different languages, you need to build different word-to-vec models, and then use those different vectors. You may build one network like this. You may use the same different vectors and train different models. For English, one training. For Spanish, another training. For Italian, another training. While training, you may have to change the structure also. You don't know, right? Maybe same structure may work, same architecture may work. Okay, so with word vector representation for different languages, you need different models. That is clear, right? Is that point clear? for word vector representations, for different languages, you need different models. Got it?
Sir, maybe not possible. Like I was just thinking.
Yeah,
So
yeah. We all need to think actually. Yeah.
Once we converted word to vec of different languages, can't we just send those vectors into the same model?
That we don't know. Sometimes we may not get the same accuracy. Because the data set size may differ, right? The word vector understanding may differ. We don't know. That's an unknown thing. Mostly it should work. 99% it should work. The same structure, the same architecture should work. Got it?
So, sir, I'm not talking about the architecture, but I'm talking about the single model.
Yeah, single model only. Architecture means model only. This model, right? This one,
But
right?
yeah, but we discussed like for each language we have to build a separate model of this kind.
We don't know. We don't know. That's what I'm saying. This like the architecture is what? One Con 1D, one max pool layer, one dense layer. This may work in English, right? It should work in Spanish and Italian also, but we don't know. Because vector representations are different, right? How you get vector representations depending on the amount of data and depending on amount of when somebody writes a document, right? There will be cultural effects in the on the document, and there will be language. There will be different kinds of languages will have different kinds of syntaxes and all, right? So it may differ a little bit. It may differ a little bit, not too extensively. That's where the architecture of the model may also differ a little bit. We don't know. That's all experimental. When you actually take the project, you should have some time. You should, in the estimation, you should have some time to experiment on whatever we were actually thinking of now. Got it?
Yes, sir, that's clear. But what I was saying is instead of building a separate model, maybe the same architecture or little bit tweaks in the architectures for each language. Yes, so what I was saying is once we convert word to vec of different languages, can't we just send all those data at once to a single model?
We can try that. Yeah, that's a good idea. Basically, yeah, you can pass all that, but it may not work. I think then you're it will not work. It will not work. It may not. It will not work because the word vectors we created in using only English corpus will have semantic similarities of the word present in English only. Do you understand my statement? The word vectors created using English corpus, what we are doing while creating word vectors, we are passing only English, right? Word to vec trained. Then only Spanish, word to vec trained. Only Italian, word to vec trained, right? The context in English may be different from the context in Spanish, the context in Italian, right? The vectors may differ, for the same word which is present in English and which is present in Spanish, right? See, it's like in Hindi and English. If you take a word, maybe food and khana, right? In Hindi, khana. In English, it is food, right? But if you look at Indian languages and the English language, it's like a little different, right? You try to write it from back to forth in English, like I don't know, maybe an example. Give me 1 second, okay?
In Urdu, we write from
No,
voice.
it is not words. That is one thing. The reverse order. That is one thing. Physical reverse order. I'm not talking about physical. I'm talking about logical also. Right? If you take English, did you write exam well? That's a question, right? In Telugu, exam baga rasava, right? Or Hindi, exam अच्छी तरह से लिखे हो नहीं, right? So exam coming in the beginning in Telugu and Hindi, but in English, right, the exam is coming at the end of the word, right? Did you write exam well? At somewhere, right? Somewhere in at the end, right? Got it? Difference.
Yes, sir.
Right? So logically differences will be there, and physically also differences will be there. In that context, right, the vectors may not get created for the same words. The vectors may not have the same number. If I say khana and food, if both are getting each other, then the same art. Did you get it? Did my statement you understood? Khana and food, they are same, words in Hindi and English, right? Food meaning is khana, right? You took Hindi corpus and trained your word to vec, and you took English corpus and you trained your word to vec. Ultimately, if the word to vec model for English is giving a vector and for Hindi is giving a vector, if both vectors are close to each other, you can use the same architecture. If they are different, you should use different architecture. But within the corpus, within Hindi corpus and within English corpus, food may be close to other, eatery, right? Maybe burger, pizza, and all that. It may be close. In Hindi, right? It may be close to chawal and dal. These kinds of words, it may be close. Got it? Am I making sense? Am I making?
Yes.
Right?
Sir,
so that way I am saying same architecture may not work. I'm not saying no. I think it will not work. If you think in this direction, right, it will not work. Please, yeah, go ahead.
Sir, I was saying that we don't need to have a single corpus for all the language words, right? So it can be one corpus for English, one corpus for, and then from there, from individual language, the corresponding vector comes, and later part or in maybe in deep learning the layers, one node can distinguish the language. So maybe that may be possible from the Vishram part.
Actually, I was actually talking like that only. Each language will have its own corpus, and we will train word to vec, and then we are trying to build a neural network, multiple neural networks for each language. Shashiram said, multiple neural networks may not be needed, multiple architectures may not be needed for multiple languages. But I am saying multiple may be needed because of the differences in languages and the structures and all that. And as you said, right, we can actually build two models. One to distinguish language, second to make the prediction. Maybe a neural network like that. It's a research kind of a thing, actually.
Yeah.
What we are actually discussing right now is kind of research. We can actually do that experimentation and publish a paper. And Girgar, what you said,
yes, sir.
Right?
Yes, sir.
Right? So that's actually I think your friend and Srinivas, why don't we write some papers and publish them?
Okay.
So I was actually thinking, sir, like, let's say there are 4 languages.
Somebody there we can.
So there are 4 languages, and in 4 languages there is a single statement which has the same meaning, and the output variable is also same for 4 documents. So when that statement is converted to word to vec, maybe each word to vec representation of the language is different, but all those 4 representations has the same y variable. So I was thinking a single model could, learn in that way.
Yeah, but when you look at it, your thought process is right. Basically, food and khana may have different vectors, but y variable maybe it is saying about some eatery, or is the statement about food or not, right? So y is one, but the problem is when you are passing data to network, the y variable is same, but x variable is not. X variable is completely different. It may act as noise on the network. Do you agree? Input is also similar, right? What are we trying to do? Semantic similarity we are trying to create in vectors y. Like and prefer should get same kind of vector, or in our previous example, SVD based example, like and enjoy, we actually try to create similar vector, because when it comes, when the likes vector goes into vector, then the network or enjoys vector goes into network, the model should think it is same. Got it? Got it?
Yeah.
Right? If you pass, food one vector and khana another vector, the network will get confused and model will not reach to the good accuracy.
Yeah.
It works like noise, it moves in one direction for some time, and suddenly it actually gets a vector for khana and y is one. It will not understand. It will try to readjust the weights in a way that it actually comes backward. Got it? You should think the network now. I am actually in the network and I'm thinking. Got it?
Yes, sir, that's right.
Theoretically, we are actually trying to understand, right, whole thing. And when you experimentally do it, right, you may find better things there. Better things and better understanding will come. Okay, so the solution for this whole thing is you build a character level based neural network. Okay, so here, instead of creating separate corpuses for English corpus, Spanish corpus, Italian corpus, and Hindi corpus, and all those separate corpuses, you take all distinct characters from this corpus, no cares, from this corpus, and this corpus, and assign numbers. Suppose there are 10 languages. In each language, there are only, there are around, there are around 20 or 30 characters. Only Telugu and Sanskrit has got 56, and they are like, 56 or 53. I don't know. So they are, complete languages. These English and all, right? They are like, half cooked. So, there are 20, 26, like, maybe 30. Average on an average 30. Then 300 characters you will have total. If you include all the special characters also, maybe 200 more. So you will get 500 characters total. From 1 to 500, if you assign the numbers to characters, they are kind of embeddings, right? For A, you assign 1, B 2, and so on. Maybe to star you assign 5, or maybe to greater than symbol you assign 500. Right? The word embedding is nothing but a number assigned to each of the character. Right? This is the representation of your data into numbers. Okay, your data is represented into numbers now. Okay, so give me, I have to take a small break here for maybe 3 minutes. If you wait here, right, I'll come back. Is that okay? I'll take 10 more minutes today.
Yes, sir. Yes.
Is it okay? Yeah. Please give me 3 minutes. I'll show you the model and I'll explain more. Okay. So I am back. Okay. So character based model, right? So instead of converting your, are you all there? Hello?
Yes, sir.
Somebody left. Sishiram Gar, are you there?
Yes, sir.
Okay, good. So, instead of trying to take word2vec and train individual corpuses on word2vec and creating vectors and then creating a different network, what I'm doing, I'm collecting all the distinct characters from all different languages and assigning one number to each of the character and then doing CNN network. The CNN network is going to be like this. So now, right, the resume 1, resume 2, resume 3, right? So the words, right? Here the total, in this, right, character 1, character 2, and so on, character 500. And Y variables are again Java, .NET, whatever. That will not change. Okay. And now we are actually going to give number here, number 10, maybe 1, 10, 5, like that. Okay. So now you can actually build a machine learning model, but it will not work well. Okay. If you build a machine learning model, right, it will not work well. Why I will explain in a moment. But deep learning model works well on this, because if you take this as a vector, this first record as a vector, that's a vector. That's a vector. Right? Each character a number, 1, 10, maybe 15, maybe 3, like that. Okay. Now if you apply 1D convolution, con 1D, what happens with filter size 3? Okay. Stride 1, padding 0. Okay. So if filter size 3, what happens? What is the dimensionality of the filter? Can you tell me? One filter I'm taking. What is the dimensionality of the filter? 1D convolution.
3 by this dimension.
3 by? Three by one. 3 by 1. Right? Because
And 3 by 1.
convolution columns are fixed, depending on the previous layer's columns, it will take the columns, right? So this is going to be the vector, right? So it will actually consider these 3 numbers and do linear combination and give one output. These 3 numbers, linear combination, give another output, right? Right? These 3 numbers, another, right? Like that. What is it doing basically? It is actually looking at consecutive characters, and so on. Then you can do dense or whatever you want to do dense. You want to do multiple filters here itself and multiple layers of con 1D, right? Again con 1D, a big neural network, and you pass Y, right? There is no meaning kind of a thing in the network now. It is actually looking at sequence of characters only. Okay. So when it takes English, right, the sequence of characters, we are not actually looking at complete word. So it may actually match. If you take different sized filters, right, I have taken 3 filters, filter size 3, 1, and maybe another in the same hidden layer. I can take filter size 3, I can take filter size 5, I can take filter size 2 also, and then merge all of them, again do one more convolution, merge all of them. So that way, right, you can take different combinations of characters where there is no language effect there. Okay, there is no language effect, there is no meaning extracted. It is almost like static, but the sequence of characters may actually decide. right? Got it? Got it? Did you get it? On multiple languages, it may work better compared to word2vec.
So here there is no semantic similarity, right?
There is no
meaning. There is no meaning.
No meaning at all. Even here also, right, what happens is, I'm actually thinking now, even here also, if you take Arabic, right, the numbers will change. The input numbers will change. Y will be same, Java, but input numbers will change. So I think we have to build a different network for different languages here also.
I was thinking the same, but as you said, like there is no semantic representation. Thought like
Probably the semantic representation is not there, but the vector will change, right? The input vector will change. Y will not change.
It is the same meaning or the same sentence of different language has different representation. The same case like the previous one. The y variable is same, but different vectors represent the same.
Yeah,
Y variable.
here also we have to build different network for different languages. But the overhead of creating vectors will reduce. And we'll use the same structure to do LSTM also, the RNN network also. There it makes more sense. It's like sequence of sequence characters we'll try to consider in considering Y. I'll talk about that later. But here also I think we have to do a different network for different language. But when you look at Flare, right, that guy is actually saying this. This model will not run on Windows. Flare NLP. Flare NLP, this model will not run on what you call it as a Windows machine. It will run on Unix only. So this guy actually promising very good results on healthcare data and all. See, German, English, Dutch, right? This is a powerful NLP model. NRE POS tag. We'll see what is NRE, what is POS tagging tomorrow. Text embedding libraries. Right, it uses the transformer networks also, and PyTorch NLP. Right, PyTorch is a very powerful. It is becoming very powerful most recently. For last 1 year, right? I would say better using PyTorch than TensorFlow. But I am actually shifting slowly to PyTorch. This is a character-based, neural network framework. It is. So we can go through this, and tomorrow we'll see more. I think I kind of. Oh, I sorry. I have to show the code, right? So I'll show the code, and then we'll think a little bit. See this? This is the character-based model. So what I did, I took the data set. I actually, divided, all the data into characters. For each character, I assigned, a number, a distinct number. This is how the text is. For this text, this is how the data is, right? For each character, there is a, this is actually the dictionary. For each character, there is a number assigned. Okay, and now so in the data set, I am actually forming the data, right? So I am passing this directly the X-train sequence of characters and Y-train because because there is no need to extract the word embedding there, right? Previously in the word2vec and glove models, I actually called a generator in the data set. But in this data set, I called a generator because in this corpus we have sentences, and that sentences have got words, and for each word there is a vector we need to pull and then create a data frame, create a data set. But in this case, right, already the whole data is converted to sequence of numbers. So the data set, the data frame has got the necessary data. So I did it in a different way here. And then the CNN layer, the kernel size 7 I said. So it's going to consider 7 characters at once. And there is a overlap also. If you look at this, there is a overlap, right? First we consider these 3, then we are considering these 3, then we are considering these 3. Like that, there is an overlap of characters. But in Word2Vec and Glove, right, that overlap is not going to be there. Maybe because of that it works. Maybe no. Maybe, may not be. But in theory, I saw that character-based models will work on multi-languages. I'll also look into it today, and you also do some googling on it, and tomorrow we'll discuss and go, right? So, on a data set, should I go with Word2Vec or character? That's a question again. You need to experiment with this and that and see which is working. Sometimes we have to combine all and then create a model also. Tomorrow, after looking at all these, I'll give an exercise. Right? If you can do that, right, that's going to give you complete clarity on the total, embeddings, word embeddings, and the models, CNN, DNN models based on word embeddings. Okay. So this is a model, and the rest of the things are same. Training and all that is same. I kind of in between I stopped it. I think these are running for long, so I would have stopped. So I was not getting good accuracy on this data set, right? I was not getting good accuracy. So tomorrow I'll talk about a more complex network on this particular data set. We'll see whether we can do it or not. Okay. So that's all for today, and let's meet tomorrow. If you have questions, right, we'll